Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about how we teach children to add and subtract fractions. In this video I'm going to talk about how we do this in 3 stages. First of all, adding and subtracting fractions and mixed numbers where the fractional parts have the same denominator. Secondly, working on adding and subtracting fractions where the larger denominator is a multiple of the smaller denominator. And finally, working on adding and subtracting fractions with denominators where the larger one isn't a multiple of the smaller one. And all the way through, I'll be focusing on how we get children to visualize what they're doing all the time, whether that's with circular fraction, with proportion bars, or with fractions on a number line. So if you don't need this video, here's a link to the next one, which is all about comparing fractions. Before you watch this video, I strongly recommend you watch the one before it in this series, which was all about equivalent fractions. You need the ideas that are covered in that video to be able to understand this one. So here's a link to it now. Okay, let's get started with some work on how we add and subtract fractions with the same denominator. Now, what a lot of textbooks tend to do is to give children lots of questions like 2/5 add 1/5 equals. Adding and subtracting fractions with the same denominator. And children tend to develop a really superficial understanding of what they're doing. Children, most of them are naturally lazy. They don't like to think about what's going on. They're just happy. Ooh, I can just add or subtract the top numbers and I get the right answer and I just keep the bottom number, the denominator, the same. Yay, I can do this maths. Happy lesson. And they instantly forget it and have no idea what they've done or why. So my first bit of advice at this stage of your teaching is to use mixed numbers with fractional parts with the same denominator, because doing so is going to force your children to think more deeply about what they're doing and try to visualize what's going on. So you can set them a question like this and ask them to talk about what's going on in their mind, to try and draw diagrams. So there's all sorts of ways that children might try to explain their thinking about a problem like this. They might talk about 2 holes and 1 hole being 3 holes, and they may be thinking about circles, or they may be thinking about bars like proportion bars, or maybe something else, and then draw their fifths, 1 and 3 more of circles or bars, and then they've deeply understood their answer. They may also try to work with a number line. If we start with 0 here and go up in fifths, don't have to be perfect to give you a great understanding of what's going on. That's 3, and so on. So we start at 2 1/5, that's going to be there, and we need to count on 1 and 3/5. So 1 is going to take you to there and 3 more fifths will take you to there. So your answer is going to be 3 and 4/5. And obviously we'd want to work on questions where you bridged a hole as well. So if this was 2 and 3/5 plus 1 and 3/5, what would happen? If they're working visually, they're going to be able to cope with that. And then we have to look at the subtractions. And remember, with subtraction, we need to reveal 2 models. So if we turn that into a subtraction, we could do that by jumping backwards by 1 and 3/5. So 1 would take us back to there, another 3/5 would take us back to there. So the answer is going to be 3/5. But we could also do it by finding the difference. So 1 and 3/5 is here. And the difference between the 2 numbers is 3/5. And you want to pick examples that reveal both structures. So if you had a question like 23 and 3/7 subtract 23 and 1/7, it's going to jump out at you that the different structure is more appropriate. But if that had just been subtract 1/7, then the takeaway structure would have been better. So that's how we play around with questions where the denominators are the same to develop a really deep understanding of adding and subtracting fractions, before we move on to harder questions where the denominators of the fractions are different. So let's have a look at one of those now. And it's nice to start with really simple questions like a half add a quarter. That's something children should be able to deeply visualise, that the answer to that is 3/4. And every child should be able to come up with a diagram for that. If not, get them to help each other out and demand that every child can draw a diagram for that, because if they can't, they've got serious problems and they're not ready for the next step. So this needs to be sorted. So they might draw that with bars or with circles or with a number line, but they should be able to come up with the idea that that answer is 3/4, and that that is the case because a half is 2/4. So when you see it that way, you can do it just as you've been doing it before. So once you've worked on that one, you could now set this question, 2/3 plus a 1/6. And you could give children the pizza parts and tell them that you're looking for an answer that's just a single fraction, and you're going to need to exchange one of these fractions just as you did before. And they should be able to come to deeply believe by doing it with pizza parts, like these, that the answer to that is 5/6 because 2/3 is 4/6. It's really important to work with these questions slowly at first, just a small handful each lesson, maybe 3 in a lesson. Time invested now is going to pay you back in the long term, because if children just learn numerical methods they don't really understand, they are just going to forget them. And you can also take this on so that they're working with mixed numbers and with the 2 types of subtraction. Subtraction as differencing and subtraction as taking away. And then eventually at this stage you're looking to generalise that if you can multiply this denominator by a number, split these parts into equal parts so they become these fractions, then you multiply the top by the same because you're splitting it in the same way, and then you've got an addition or a subtraction that you can do as before. And in explaining that this way, I'm using the ideas that we developed in the previous video. So if this is going a bit fast for you, you need to go back and pay more attention to that video before you come back to this one. Or you can just ask me questions in the comments or have a go at me on a Sunday when I go live at 9 AM each Sunday British time. And I will happily go through questions just for you and chat to you until you're happy and confident that you can do this. Now, what about the ultimate challenge, stage 3, where the denominators are different and the larger denominator isn't simply a multiple of the smaller denominator? And we're going to have to slow down even more and really delve into these questions. Let's have a look at one now. I would set a question like this one, 2/3 add a quarter, and tell my children that I'm working with that I want them to come up with an estimate for the answer and some diagrams. Now, if they work in groups and challenge each other, they should be able to puzzle out that this is a bit less than 1 because a quarter is smaller than a third and there's a third gap left for 1. So it's going to be a bit less than 1. If they're struggling to visualise it, of course we can use apparatus. That's what it's there for. So for 2/3, add a quarter. It's going to look something like that, and they should be able to confidently see now that it's a bit less than 1. And if children are starting to come up with estimates like 9/10, then that's fantastic. Great work. Exactly what we're looking for at this stage. And you can test that gap with a 10th bit of a pizza and see if it fits exactly or not. It doesn't, and that can lead to some more thinking and reasoning and estimating. The biggest mistake teachers can make is to teach children a method without going through this stage of getting them to deeply play around with and understand what's going on. Because they won't remember it, and you're just going to have to teach it again and again. And they're not only going to struggle with this topic, they're going to learn that maths is about recipes and spells that you don't really understand. And it is if you teach it that way, and it isn't if you teach it properly. So where do we go next with this to get an exact answer? Well, we're going to use the proportion bar, which I introduced again in that last video. Let's have a look at that now. So again, I'm going to use mathspot.com, type that into my URL, go to manipulatives and go to bar modelling. Because we're using a proportion bar, we want to make that bar nice and big and create some more bars that are the same length. because it's only when it's nice and big that we can see the level of detail that we need to see. So I'm going to create a bar for the 2/3 and a bar for the quarter that we're going to add to it, and then a bar to illustrate our answer. So you have to click on each bar before you divide it into parts and fill it. That's our 2/3. Select the second bar. Oops, gone too far. Right, it's in quarters, and fill that. So that's what we're trying to add. And once again, we can see that the bit we're adding on is a bit less than the space. So the answer is going to be a little bit less than 1. But how do we work that answer out exactly? Well, we need to break that third bar into a number of pieces that work for both those fractions. So at 4 pieces, we've got quarters, but it doesn't work with the thirds. So we carry on. At 6, it matched the thirds, but not the quarters. So we're going to need to carry on. At 8ths, we're matching the quarters, but not the thirds. That works, but the thirds, they've got no match in that, so we carry on. 9ths, they're matching the thirds, but not the 8ths. Carry on. 10ths don't work for either. 11ths don't work for either. 12ths. And here we go. Because the 2/3 are 8/12ths, and the 1/4 is 3/12ths. So 12ths are going to work. So if we fill in 2/3, that's 8/12ths. We need to add on another 3/12ths for the quarter. And there we have our answer. There's the 3/12ths that have come from the quarter. So that is an exact answer. 2/3 add a quarter is 11/12ths. And then you want to give children another question, maybe this one, 1/2 plus 2/5, and let them puzzle at it with the pizza parts, with the proportion bar. And quite quickly you'll need to move on to questions that only work with the proportion bar, because you've got a limited number of sections for pizza parts. And you can go on to questions like 3/4 add 2/5, which is great because it's going past 1. For every question, you want children to estimate the answer, make them visualise it, make them able to sense check the final answer they get. Get them visualising all the time, whether it's on a number line, with circles, or with proportion bars. They need something here or it's not going to stick. So how do we develop a general, reliable method? Well, let's just look at the question I suggested last. 2/5 add 3/4. If we use array, that's a square of 1. It's 1 unit that way, 1 unit that way. We can show 2/5 if we cut it into fifths. That is 2/5. And we can show 3/4 at the same time if we cut it into quarters the other way. So 2/5 is going to be 8/20. And 3/4 is going to be 15/20. So that is going to become 8/20 plus 15/20. Well, 5 of those are going to make a whole, so that leaves us with 1 and 3/20. And you can do several of these squares and colour them in and move the parts if that helps. Your 2/5 is going to be 8/20. Your 3/4, if you take time to draw a second square, is going to be your 15/20, and then you can draw squares in 20ths to fill them up. So gradually you get this generalization that you can always find a denominator that works for both of them if you multiply these two denominators. And then if you use equivalent fractions, you can find the answer. Of course, there are ones that contradict that rule slightly. If you consider something like 5/6 plus 1/9, using the rule I've just described, you'd end up with a denominator of 54. But you can actually do that with a denominator of 18. So sometimes there's a smaller denominator that works. And if you've got children who are playing with this, with apparatus, with structure, they'll come across those as well. And that's a really powerful thing. And of course, you can work with mixed numbers as well. If they've got used to those with the easier examples where the denominators were the same, they can then apply the same thinking to these situations once they've got the hang of working with the different denominators effectively. So your extension work has really been mainly built into this lesson already, because it's a low floor, high ceiling lesson working with apparatus and asking children big questions and asking them to make connections and justify and explain their answers. There's a huge amount of extension work as you go along. Another powerful extension strategy you can use is reification. That's just where you give children a calculation and ask them to make up an imaginable story for it. It doesn't have to be realistic, but it has to be something you can imagine. So this might be, I had 3/4 of a cake left. Someone came along and ate 1/3 of the whole cake. How much is left? But when you work on classes that do this, you encourage them to be creative and they can come up with some fabulous examples for you. Imaginative and entertaining. And it's much better than working with practical problems they have to solve, because the process of turning abstract questions into real situations opens up more doors and makes more connections than going the other way. Of course, you can work on practical problems too. So your takeaways from this video are that there are 3 stages to developing children's understanding of adding and subtracting fractions. Here they are. And at every stage, you need to get them visualising what they're doing, whether that's with a number line or with proportion bars or with circles. They need something there or they will forget what they've learnt. We also want to get them estimating their answers, especially at the 3rd stage, and then sense checking their answers. Is the answer that they've come up with close to their original estimate? Does what they've done make deep sense to them? Okay, that's it for this video. Well done. Thank you for putting the time and effort in. If you have any questions, please ask them or come and ask me live on Sunday mornings, or you can use my Facebook group, which is Expert Primary Maths Teaching. If you could possibly just click on like or subscribe to this channel, that'd be great, and then you can find it again. And of course, if you can introduce your friends to these videos or other teachers that you work with, that would be awesome. You can find out more about me and what I do at authenticmaths.co.uk. And of course, if you could share your stories of using these strategies with your children, that would just be lovely. Love hearing your stories. Thank you so much for watching. Have a great day. Hope to see you soon. Bye for now.